In section number 6, we're going to be learning about services. And services, they are an abstraction concept that defines how to access a logical set of pods in Kubernetes. If you go to the Kubernetes documentation, there's a great explanation how services work, but just to give you a very short summary, just imagine a situation where you have 10 pods of the same application running, and you want to take the traffic coming from the internet all the way to these pods. Now, the issue with that is that a Kubernetes cluster is very dynamic. So nodes are coming up and down, and the same way pods are also coming up and down. Pods, they're assigned IP addresses, but every time a pod goes down and it comes up again, the IP address might change. So it's really hard for you to track down IP address in a very dynamic environment such as Kubernetes. And that's where services come in. So services are basically a single point of entry, and it works pretty much like a load balancer. Of course, that is not as powerful as a load balancer, but it is a single point of entry that distributes the traffic to all of the pods behind it. So in a way, you can think of it as a load balancer. So let's start coding, and I'm going to be explaining a few things along the way. Let's start by creating a service for the front end. So I'm just going to create a file called service. And the definition of a service is it's very simple as well. So the API version is v1. The kind, you might have guessed already, it's service. Metadata. So the name of my service is going to be front end, and the namespace is going to be team1. Then for service, we also have a specification, so a spec. Remember when we declared the deployment that we had a selector and then match labels? With the service, it's pretty much the same. So we have selector, and the only difference here is that we don't have match labels, so we can actually put the labels directly. And just to go back to the deployment very quickly, we can see that the labels are app front end. So we need to make sure that we're specifying the exact same ones. So app front end. And what this means is that if I have 10 copies of the front end running, every single copy that has the label app front end is going to be behind this service that I'm creating. Now, because services are a point of entry, they also need to have their own port. So to declare a port for service, same way I just do ports, like I did for the deployment, and then port, and I specify the number, which is going to be 8080. So I'm basically just using the same number that I used for the container. And then finally, we need to specify the service type. Let's take a look at the different service types. So these are the service types that we can choose from. So we have cluster IP, node port, load balancer, and external name. So the cluster IP basically exposes the service in a cluster internal IP, which means that the service is only reachable from within the cluster. Then the node port exposes the service on each node's IP at a static port. And this basically means that the service is going to be running at the same network stack as the host, so you can actually reach it from outside the cluster. And you can do that by specifying the node IP address, so the IP address of the host, as well as the port that you define. The third type is the load balancer, and this is basically if you're using a cloud vendor like AWS or GCP or Azure, and you specify the type load balancer, what Kubernetes is going to do is it's going to create a load balancer in that cloud provider. So in my case, if I declare a type load balancer, Kubernetes is going to create a load balancer on AWS. And so if I want to access the service, I basically just need to go through that load balancer that is going to be created for me. And this is another way of exposing services externally so that you can access them outside the cluster. And then finally, we have the external name, which maps the service to the contents of the external name field. That can be a CNAME record. And this is usually used if you want to point a service to another service which is not necessarily running inside the same cluster. Now let's think about which one of these makes more sense for our front end. So with the front end, we should be able to access from outside the cluster, which makes you think that, well, maybe we need a load balancer. But the thing about load balancers and services is that if you have, let's say, 20 services, and you decide to create a load balancer for every single one of them, that can be very costly over time, especially if you increase your number of services to 20 to, let's say, 100 services. Imagine running 100 load balancers. Plus, sometimes you have services that you don't actually have that much traffic, so you don't need something as powerful as an entire load balancer just for that. And if that's your case, you might benefit from something called ingress. We're going to get to ingress very soon. It's actually the next section. But just to give a sneak peek at ingresses, with ingress, what you can do is you can have a single load balancer and have multiple services behind that load balancer. And that's a great way if you don't want to span with multiple load balancers. So you basically just have one and you have multiple services behind it. And that's what we're going to be doing in this challenge actually for the front end. So for the front end, we're not going to deploy its own load balancer. We're actually going to leverage ingress. Now, when you leverage ingress, that means I cannot create a load balancer separately for the front end. So all I got to do is to choose the cluster IP type of service. So if I declare as a cluster IP, basically right now, I cannot access the front end from the outside because cluster IP means the service is only reachable from within the cluster. But like I said, in section number 7, the next one, we're going to work with ingress. So for now, let's just go with cluster IP. So the type of my service is going to be cluster IP, and that's all we need. Let's just deploy this. Great, now you can do kubectl get services. And here you can do service or SVC. This is short for service. Team 1. And then we can see the name of the service, which is front end, the type, which is cluster IP. Now this is the IP address that has been assigned to the service. And we can also see that there's no external IP address. If we had chosen load balancer, we would see an external IP address or a DNS name. Ports, it's 8080, and it's listening for TCP traffic. Now I just wanted to help you connect the dots here. So how does traffic coming to this IP address actually gets to my front end pod? If I do kubectl get pods team 1 and then -o for output, and I specify wide, this is going to bring more information about each one of the pods. For the front end, we can see that under IP, we have the IP 10.0.90.106. So this is the IP that has been assigned to my pod within the cluster. And if you want to see the mapping between the cluster IP and this IP, you need to get the endpoints. So kubectl get endpoints, team 1. And so the endpoints resource is the one linking the service to the pod. Right now, I only have one pod for the front end, so that's why you only see a single endpoint. But just as a test, let's increase the number of replicas of the front end and see how the endpoints are going to change. So to increase the number, I need to edit the deployment. Deploy is short for deployment, and then front end, team 1. So this is the YAML for the deployment. And really, if you want to change something, you should really do in the deployment file. But I'm just changing inline just to quickly show you how this works. So replica, I'm going to change to 3. Save that. And it says that the front end has been edited. If I get the pods again, so you can see the 2 more pods that are being created for the front end. Let's just wait a few seconds. And now they're running. So in total, we have 3 pods for the front end. And you can also see that we have 3 IP addresses. This, and this one. Now, if I get the endpoints again, so kubectl get endpoints. There it is. Now we see 3 IP addresses in the endpoints instead of just 1. And so what all this means is that whenever traffic comes to the front end service, which is this IP address, the traffic will leave the service and actually go to one of these IP addresses, which are the IP addresses of the pods. And this is how basically services connect to pods. Let me quickly edit again and go back to one replica so we don't get confused. All right, so if I get pods, we should see one. The other one are being terminated. Okay, great. All right, so we have a service for the front end. Now let's create a service for each one of the other microservices. So Auth Api is the next one, and this is going to be very similar to the front end. And with Auth Api, we don't have that discussion because Auth Api is supposed to be accessed only internally within the cluster by the front end. And that's why we're using cluster IP as type. So let's quickly deploy that. Now moving on to TODO's API, which looks exactly the same as the other ones. It's also cluster IP because the TODO's API is only going to be accessed by the front end within the cluster. So let's apply that. Next, the users API. And last but not least, Redis. So let me deploy that. Okay, we've deployed all the services. So I can just get services and we can see which services we have deployed. So we have Auth API, front end, Redis, TODOs, and users. Note that we don't have a service for log message processor. And that's because no other service needs to access log message processor. It's not even listening on a port. So since log message processor is not supposed to receive traffic from anything, that's why we're not creating a service for it. All right, that's all we had to do. And in the next section, we're going to make the front end accessible via the internet.